Semiconductor are the materials which have conductivity between insulators and the conductors. They are divided into two types: intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductors are also known as pure semiconductor or natural, while extrinsic semiconductors are known as impure semiconductor or artificial semiconductor. Obviously, the conductivity of extrinsic semiconductors will be higher than the conductivity of intrinsic semiconductors because extrinsic semiconductors contains doping. Doping are of two types: low level doping and high level doping. When the dopant upon pure semiconductor concentration is 10 to the power 8, then it is low level doping, and when it is 10 to the power 3, it is high level doping. Example of high level doping diode is tunnel diode. Extrinsic semiconductor are further divided into two parts: p type and n type. What is p type? P type is the intrinsic semiconductors plus trivalent impurity. And what is n-type? N-type is intrinsic semiconductor and pentavalent impurity. What is trivalent and pentavalent impurity? Talking about the periodic table, going to the third group and the fifth group. The third group which have 3 valence electron and the fifth group which have 5. This is trivalent and this is pentavalent. And in the fourth group, they all are semiconductors. Why carbon is not a semiconductor? Because it has energy gap of 5 to 6 electron volt. What is energy gap? Can there are two type of band: valence band and conduction band. So electron moves from, so there is a gap between valence band and induction. If the gap is more, conductivity is less. E.g., yani energy gap is inversely proportional to conductivity. Similarly, for germanium and silicon, the gap is not very much. Now, you will ask, uh, in germanium and silicon, germanium energy gap is 0.72 and silicon energy gap is 0.1. So, germanium is better. But why we use silicon everywhere? Silicon is used everywhere. Silicon is preferred. Uh, Although it is less conductive than germanium because silicon has a better thermal limit, better voltage rating, better power rating, better availability in earth crust, and better current rating. With diagram for p-type semiconductor: bonded, unbonded. So incomplete, so it will be a hole. N-type, bonded, and the extra, which is a free electron which will move. So the p-n type semiconductor. This is a diagram for p-n type. This is p and this is n. P is majority holes and n is majority electrons. These are electrons. The layer of immobile positive and negative ions which have no free electrons and holes are called depletion layer. This layer is depletion layer. During forward bias condition, the number of immobile ions are less. Therefore, depletion with layer is less. Immobile ions, zero holes transfer. During reverse bias, immobile ions become more depletion with की length बढ़ेगी. Classification of solid materials on the basis of electrical properties: conductors, insulators, semiconductors. Effect of temperature on semiconductors is directly proportional, and while on conductors is 1 upon temperature, yani inversely. Knee voltage or cut-in voltage. A minimum true voltage is required to start conduction is for in forward bias diode. For germanium it is zero point 0.3 volt and for silicon it is zero point 0.7 volt. Knee voltage. The VI characteristics for PN junction diode. I and V graph. Forward bias condition exponential, and then reverse bias condition like the Zener breakdown. Breakdown mechanism is of two types, Zener and avalanche. Breakdown occurs in the Zener biasing diode. Equivalent circuit of diode is this. Ideal diode, ideal diode graph. Knee voltage is 0, I naught is 0, forward resistance is 0.